11th class also, work energy in power, when we did laws of motion, when we did rotational motion, that time also rotational analog of force was torque. So same torque is applied here also in electric charges. When electric charges come, electrostatic forces come. So their rotational analog becomes torque. So basic simple formula, a very small derivation is that net force always remains zero. When we perform this derivation you can see later on, because this derivation part, all these will otherwise take a lot of time. So final product that we get is P cross E, PE sine theta. So P is the dipole moment, E is the electric field, and theta is the angle between the electric field and dipole moment. So this is how we get the torque and value of dipole moment. Dipole, I hope you understand. Dipole is a positive charge and a negative charge, which are separated by a small amount of separation. They are separated by a small amount of distance, and both have to have the same magnitude and the opposite direction. That is what is meant by a dipole. So its strength is calculated by taking any of the charges magnitude and multiplying it by the separation they are containing. This is what we call as the dipole. An electric field for a point charge is given by K Q by R square, where K is what? K is a constant. This value of constant, we write it as 9 into 10 to the power 9. Q is the charge, R is the radius. Fine. So all these things, these are very basic details. I think you will be able to see it up through the videos only. I think that is better, because that will save your time also. Whatever things you already know, that you can skip forward. For the notes also, you can pause and note it down. I think that will be better. And wherever you get stuck, I'll help you with that. All right, Madhya?
Yeah. Okay.
So rest of the portion, we did it. Yes, one more thing, Madhya. The work of this torque and the direction of this torque. This direction of this torque is basically to align the dipole parallel to electric field. So in whichever direction your dipole is there with the electric field, making whichever angle. So the dipole tries to align it with the electric field. If suppose in this first figure, dipole is arranged in such a manner, some angle theta is being made. So torque will try to rotate it clockwise, so that ultimately this is the final position. Similarly, if it is anti-clockwise, the torque will work anti-clockwise if it is located in such position. Here also theta angle would be made, angle would be obtuse. So the work of direction and the direction of torque, these two things, work and direction of torque, is determined how the dipole is in getting aligned with the electric field. These are just the two things which you have to remember. We saw very basic questions. Among these special cases we had seen, see, these special cases are important for your theoretical questions in your board exams, as well as in your entrance examinations for NEET, J and all. These questions are very important. 1 marker questions, 2 marker questions. So definitely these won't come in your long answer questions or short notes to write all the details, but in your very short marker questions, these can be asked. See, best way to remember equilibrium is it can be stable, it can be unstable, it can be neutral. Now, how to identify whether a body that is in equilibrium is under stable equilibrium or unstable or neutral? So best ways, just displace the body's initial position. See, for example, if I take a bowl and I put a ball in it, and if I displace the ball, what will happen? The ball will move and it will ultimately come back on itself. Again, the ball will move into the other extremity. It will come back on its own by the gravitational force, right? So on disturbance, what is happening? The object is coming back to its mean position. That is known as stable equilibrium. But see, if I invert the ball, right? If I invert the bowl, I have kept the ball still here. Now, if I move it, what will happen now? The ball will move away straight away. It won't come back. So this is still, the ball is in equilibrium. But since it is not reaching its own position, original position back, we say this is unstable equilibrium. And if at every point neutrality is being maintained, equilibrium is achieved, we say this is a neutral equilibrium. So same way in the formula PE sine theta, we can keep on putting the values of theta. If dipole and electric field are parallel, theta will be 0, torque will be 0. So in this case, F net is also 0, torque net is also 0, means rotational equilibrium also exists and translational equilibrium also exists. And see, in this case, what is happening? If we displace the torque, see, this is the original position, this blue one is the original position because it is parallel. If we displace the dipole moment, torque will bring it back. So this means this is stable. Our original position is being achieved. Yes, Madhya, say.
Ma'am, the case will be given to us, right? Like if the dipole is
Yes,
parallel or
yes, yes.
anti-parallel.
Case will be given in the manner that the entire sentence could be written to you, dipole is parallel to electric field, or it can be given to you that theta is mentioned. Theta is 0 degree, theta is this much degree, this can be.
So we just
Angle
have to
theta,
put the formula and then
yes,
find out what torque is.
what torque is, exactly.
All right.
It can happen that angle is not known, but in that case, the values of the triangle sides will be given. So using your trigonometry, you can find out what is sine theta. So
Okay.
somewhere or the other, these will be mentioned. Similarly, if it is anti-parallel, this would be 180 degree. F net will again be 0, torque will still be 0. But see, in this case, see, this is the original position of the dipole right now, anti-parallel to electric field. Now, if I disturb it, it won't come back to its original position, right? This would, torque will do what? Torque will align it again. So the original position was this, but now the torque dipole will be this because of torque. So we say this is unstable equilibrium. Equilibrium is achieved. F net is
Ma'am,
0.
can you repeat this once? Can you please
See,
repeat this?
see. Just look at these blue one. This is the original one according to the question. Anti-parallel, 180 degree, exactly opposite to each other, dipole moment and electric field, right?
Yeah,
Making an
yes,
angle of
yes.
180 degree. So F net is 0 and torque net is 0. So equilibrium is there. But how do we determine whether it's stable equilibrium or it's
Because it's in
unstable?
opposite direction.
No, they are in opposite direction. That is telling us that it is anti-parallel. All
Oh,
right.
yes,
To
ma'am.
determine whether it is stable or unstable or neutral, that is also a challenge. No, just by seeing the F net is 0 and torque net is 0, we can just figure that this is equilibrium is 0. They are in equilibrium. But we also have to identify whether it's stable or unstable. So what did we say? We just have to displace it. See, in the previous question, when we displaced it, so because of action of torque, it came back to its original position. So we said this is stable equilibrium, right?
Yes, ma'am.
In this case, if we are disturbing it, let's say this is yellow position is the disturbed position. Torque will do what? Torque will align it to the electric field like this, right? This is the work of torque.
Yes, ma'am.
So original position was this. Final position is this. Is it same?
Okay, no, no,
No.
right.
So that's why we are saying this is unstable equilibrium. Got it? Is this part clear to you, Madhya?
Yes.
All right. So in any case, no, this is not just for your dipole and electric field and torque. In anywhere in physics, you have to check no, whether something is in equilibrium. Just check the net forces. Net force is 0, so that will give you translational equilibrium. Net torque is 0, that will give you rotational equilibrium. Right? But to determine whether it's stable, unstable, or neutral, that will be given by this only. Just disturb the position and check whether it's returning to its original or not.
Oh,
All right.
yes, ma'am.
Okay, last case is when this is perpendicular. If this is dipole is perpendicular to electric field, this time it won't be 0 because torque is PE sine 90 degree. So torque will be PE, right? And now this is the maximum value of torque because sine 90 is 1 and 1 is the
Yeah.
maximum value that is
Yes,
possible,
yes.
right?
Yes, ma'am.
This is the maximum value possible. Torque is PE sine 90 degrees. So torque is PE. So this is the maximum value. So in this case, see, F net is 0. We are getting translational equilibrium. Why are we getting translational equilibrium? Is because you have a charge plus Q and a charge minus Q. So the forces, we have a formula. I don't know, Madhiya, if you are aware of this formula or not. F is equal to QE. Have you heard of this formula?
Yes, ma'am.
All right. So using this for positive charge, this is plus QE. And for negative charge, this is minus QE. That's why we are seeing continuously F net is 0. And torque, since this is not 0, so it means the third case is not in equilibrium. So if a question by chance in your board exam is asked, give a case where the dipole is not in equilibrium. So you will mention when the dipole is perpendicular to electric field. Or it
Okay.
can directly be asked to you what is the state of equilibrium when dipole is perpendicular to electric field. So you will only tell that plus QE minus Q is 0. So F net is 0. That is we are having translational equilibrium. But since we are not having the value torque as 0, we'll get torque as P. So that is giving us no rotational equilibrium. So this is not in complete state of equilibrium. Fine?
All right, ma'am.
Okay, let's just wait for 2 more minutes. I think most of them have joined. Austin, Tarif, Humam is joining. Atia Sultana. Who is this Atia Sultana? Atia, am I
Yes, ma'am.
audible to you?
Yes, yes,
So this is your first class, Chavez, your name.
yes, yes, sir.
Okay, okay. So you've joined quite late. You had to join a little bit earlier today. I had discussed
Yes,
everything with Madiha. Your name is Chavez, no?
yes, yes, ma'am. Yeah,
All
I
right.
actually went for prayer, ma'am, so I came late. So,
Okay, okay, okay. So I'll just brush up you after the class. We're just doing talk. Let us just wait for 2 minutes. I think most of the students have joined. Faiza is joining. Then I'll begin with it.
Ma'am,
Yes, Madhya.
ma'am, the case 3, it's like the condition for neutral equilibrium, right?
No, this is not the case of neutral equilibrium, because when we just say the term no equilibrium, when this word is mentioned to you, this comprises of two things. One is your translational, other one is your rotational. And if I am seeing a body is in equilibrium, whether neutral, stable, unstable, that means both are zero. But in this case, only this was zero, this was non-zero. So this is
Okay,
not a
okay.
case of complete equilibrium. So we do not move forward to whether it's stable, unstable, neutral, because since it is not a complete equilibrium. All right.
Yes, ma'am. So it's a translational equilibrium.
It's just translation. Exactly. So this is just because in your questions, if something gets modified, usually so much details are not asked in your exam, but if just in, because MCQs can sometimes be tricky, with the help of these objectives, the values options that are provided. So
Yes.
just in case for those things, just remember all these.
All right.
Yes, so I think okay, Madiha is here, Shave, this is, and Austin, Faiza, Humam, and Tarif. Tarif, you're not appearing for the after class assessments. Or are you attempting all these? Because I haven't received any of your score, Tarif, regarding the after class assessments. Just let me know whether you're attempting it or not. At least you should attempt all these after class assessments. These marks are not going to be added anywhere. It's just that so that whatever has been studied in the class, you are studying it and revising it, and if something has not been understood to you, that gets clarified when you give the after class assessment. Those are not, you're not judged based upon them. So all of you should attempt after class assessment. These are just 4 to 5 questions, and only that topic comes which we discuss in the class already. All right. So, yes, class, in the store portion, no, one important question that is left is, see, the basic questions regarding PE sine theta, P cross E, value of dipole moment, electric field is we have already seen. Some good questions come from it that can be related to your class 11th topic. SHM and waves you must have done in your class 11th. So it is related to that. So you have to relate it by yourself, but since we already have a question, we'll practice it in that way. Shaviz, just tell me one thing. Do you have some idea about this chapter? This is completely
yes,
new to you.
no, some idea. Yeah.
Some idea you have. In your school, this lesson is currently going on.
Yes, sir. It's currently going on. Like it's ending now.
Okay, okay, okay. And Madhya, what about you?
Ma'am, yes, this lesson is complete in our school.
Okay, okay. So see some concepts of SHM. See, SHM, that is simple harmonic motion. So what we are going to do, we are just going to revise the basic angular SHM and conditions for angular SHM. Because see, from this part, no, you don't have to write down all the theory part. It's just that a very, very brief recap for all of you, because since it's not been a very long time that you have been studied this lesson, since your class 11 got over this year only, but let us quickly brush it up. See, for simple harmonic motion, no, because sometimes you have to prove some charges are in SHM. So if some charges are in SHM, so that will again relate to the conditions of SHM. Now, conditions for angular SHM, oscillations exist. There's a mean position. F external, whatever is the external force, disturbs its mean position. This is the mean position, disturbs its mean position and leads it to extreme position. Now, the torque, that is the restoring torque. This is the extreme position. Now the restoring torque brings the body back to its original position. This is the torque that we are referring to. Because if the charges are present instead of these balls, then we have to apply all these concepts exactly. So torque is equal to minus k theta. F you must have heard of. F is equal to minus kx, where F is the restoring force. This is the restoring force. X is the displacement from the original position. Let me see if it's written or not. No, it's not there. See, this is the restoring force. This is the spring factor. Spring factor is just a constant. This is the spring factor. This is displacement from mean position. So exactly its rotational analog is written as force becomes torque. Spring constant remains same here, but linear displacement becomes angular displacement. That is angle swept by the pendulum or whatever device you are taking. So if somehow you are able to satisfy this condition, torque is equal to minus k theta, and k's value can be anything, then you can prove that your system is in equilibrium. If somehow you are seeing that this is torque is equal to minus something which is not equal to minus k theta, so then you can directly conclude the fact that the system is not in equilibrium. Now, angular frequency can also be asked to calculate it, and time period as well. Just remember, this constant k is there divided by moment of inertia. So omega, that is angular frequency, becomes under root k by I. Time period is 2 pi by omega. Omega is 2 pi by t. T is the time period. Omega is angular frequency. I is the moment of inertia. So I'll just give you a question that relates how electric dipole, when this is placed in a uniform electric field, whether it's in SHM or not. And questions are there. I'll show you how angular velocity and time period is also calculated. But just before that, no, write this part, then only that clear clarification of question will start. Madiha and Chavez, you just start writing from here. And Chavez, I was telling this to Madiha as well. Just take the video lectures, whatever topics have been completed, at least go through the video lectures. And wherever you're not able to understand, let me know. Once this chapter gets completed, in any ways, I'll share the OneNote link with you so that whatever have been missed, you can note it. All right, but go through
Yes.
the video lectures and let me know if you want to arrange a class. I think Austin has also not started from the starting. So if you people need any classes, just let me know. So note down it from here.
Ma'am, where can I get the video lectures?
We'll send you the video lectures. All right, the links, it is available on YouTube. So
Thank you.
YouTube links we'll send. All right.
Ma'am, I didn't complete. Can you let's just move it? Yes.
Now see class, this question, this is what I was referring to. These types of questions have come in your exam. So very little chances, but the concept remains same. So just understand the concept. An electric dipole is placed in a uniform electric field. You have to show that its motion is in SHM. So this is not asking you to check whether it's SSM or not. It's just mentioning you that you have to prove that yes, this is in SHM, as well as you have to calculate the time period. See, once SHM is calculated, you can get the value of the constant spring factor. And once you have K, angular frequency, time period, whatever is that you can calculate it. Fine. Now see, this is the condition that is given to us. Electric dipole is placed in a uniform electric field like this. So torque will try to do what? What we have been studying. In the last class also we had studied this. Today also we have revised this. That restoring torque tries to align the dipole moment to electric field, parallel to electric field. If this is the original position of dipole, this is the final position of dipole that the torque wants to do. So the angle that is swept is theta. So we have to prove that this restoring torque, this is directly proportional to minus k theta. This is our condition. If you are able to satisfy this, you will get your result as SHM. This is what you have to do. This is your target. If rotational things are given, whenever you have translational, always use minus kx. These are the two conditions in SHM whenever you have to relate. So see class, restoring torque, we have seen minus PE sine theta. Actually, the formula that we had seen is P cross E only, right? P cross E only. But PE sine theta, we are putting this minus sign because this is restoring. Otherwise, in general, what all the torques we had studied in the last class, all these torques, these were not restoring, no. These were in this question also that we had seen, this wasn't restoring torque. It was just the torque on dipole, right? That was trying to align it. So that's why we didn't put a negative sign in all these questions, but here we have to put it. Now class, there's a small angle approximation that says that not just for sine theta, tan theta and sine theta, they almost become equal to theta. This is a small angle approximation. Small angle approximation, just a second. See, small angle approximation says that if your angle, this is a very small angle, that is almost less than 15 degrees. 15 degrees, it is less than 15 degrees. So this angle, we call it as a very small angle. Your huge larger angles are those 30 degrees, 40 degrees, 45 degrees, 90 degrees, all these. So small angles are all these less than 15 degrees. Suppose you have sine 7 degree. So sine 7 degree, sine 2 degree. Instead of solving these, no, just equate the answer to theta. That will also. So if you have small angle approximation, you can say sine theta is approximately equal to theta and tan theta is also approximately equal to theta. So what can we say? If this is the case, sine theta is almost equal to this. We know torque is directly proportional to theta and torque is directly proportional to, from here you can say this is minus PE theta. Our equation was torque is equal to minus K theta. Can we notice something? See, torque is equal to minus PE sine theta. This is theta is the angular displacement. Do not write it, anyone. Please do not write it. Whenever I'm writing it down, I'll give you sufficient time to copy it. Please try to understand this first, because once this is missed, then you won't be able to remember. And wherever you're not able to understand, either send me in the chat box. Chat column is always open to you, or you are welcome to unmute yourself and ask the doubt, whatever it is. You can interrupt me in between also while I'm teaching. Anything that you're not able to understand, at the end of the question you want me to repeat, let me know. So this is angular displacement. Now see, if this is angular displacement, it means we can have poundar K, because let's not write sine theta. Let's write it as theta only, because we have used small angle approximation, because we know obviously this would be a very small angle if it is rotating. So what is the constant that we are getting? This means system exhibits SHM. This is proven because this is the formula that we are getting back. Condition of SHM is satisfied. This is the condition of SHM. Now, if you have to find out the time period, see, omega is K divided by I. What is the constant we are getting? PE divided by I, right? So this is omega. Time period will be 2 pi by omega. So time period will be 2 pi by, this will be under root PE under root I. This will be, right? So, or you can simplify it, write it as 2 pi under root I by PE. This is 2 pi under root I by PE. Omega, this is angular frequency, this is time period. Just remember these two relations. All right, T is 2 pi under root I by P. This is the time period which you had to calculate. All right, class. See, I have to open up my fast class. So here it's Maghrib time. So I'll tell someone to scroll it. Just copy it down. After this, I'll get it clarified with you. I have to open the fast and I have to pray. I'll come back in 10 minutes. Yes, class. So we have been discussing the, I hope you all have written it.
Yes, ma'am.
All right. So see, this was when the electric field was uniform, right? When the electric field was uniform, this is the case that we were discussing. Now, if the electric dipole is kept in a field that is non-uniform, then what will be the case? What is left that we have to discuss. So we'll do this in the form of question only, because only in the form of questions these are asked if it is asked. See, if it is a non-uniform electric field, so it means at end of one charge, you'll be having electric field some E1. At the end of another charge, you'll be having electric field E2. So your force 1 will be QE1, force 2 will be QE2, right? So F net, now this time, this won't be plus QE minus QE, right, class? Do you see this? At the previous question, when we were solving the previous question, that time your electric field was uniform. So it was E near the vicinity of plus Q, and it was plus E near the vicinity of the second charge. But this time, since it is non-uniform, at the beginning, the layers must be E1. At the end of it, these must be E2. Something different fields will be there. So when we are calculating the net force on the dipole, if you calculate net force on dipole, see, F net will be equal to plus Q1 plus Q1 minus plus QE1 minus QE2. So F net, this is not equal to 0 this time. So we are not getting translational equilibrium. What are we getting? We are getting the value of a proper translational motion. So it means translational equilibrium is not existing, proper translational motion is existing. So when F net was 0, we could conclude the fact that this is under translational equilibrium. But this is non-zero, this means there is a translational motion. Now, what type of translational motion is there? How the dipole is moving, whether it's able to rotate or not, that is none of your concern. You just have to find it out whether it's under an equilibrium or not. That's it. So in this case also, since you can figure it out, this is under translational motion. No equilibrium is achieved, right? And what about torque? See, if we talk about torque, so obviously torque portion is very simple. Torque is PE sine theta, right? So torque is obviously not equal to 0 because PE sine theta is containing any values. So somehow this will be rotational motion. This will also be having rotational motion. So no translational equilibrium, no rotational equilibrium. The body isn't under equilibrium. So what is the final motion? What will you conclude about the dipole's motion, right? If someone asks you, what is the motion that you have studied? This is what you have studied regarding the translational and rotational equilibrium. What is the motion? So you will say final motion. It's a combination of translational motion, it's a combination of rotation. Yes. Combination and rotational both. So final motion. This is a combination of translational as well as rotational motion. So if a non-uniform electric field is specified by any chance, so this is exactly what you have to write. Quickly note it down. Then one last question we'll see, then we'll see some other topic not related directly to torque. See this next question. This is the last question that we'll discuss from this topic. An electric dipole consists of two opposite charges of magnitude 1/3 into 10 to the power minus 7 coulombs. So they are separated by 2 centimeters. The dipole is placed in external field of 3 into 10 to the power 7. What is the maximum torque that the electric field exerts on the dipole? Very basic formula based question, so that at least at the end we are just concluding with the formula. 2 into 10 to the power minus 2 meters is the separation. Charge is 1/3 into 10 to the power minus 7 coulombs. This is the charge that is given. Electric field is 3 into 10 to the power 7 Newton per coulombs. Torque will be PE sine theta. Now see maximum torque. So what have we studied for maximum torque? This will only be P. This is the third case which we discussed. Remember sine 90 degree. Torque is P. That is going to be maximum. That's how you have to apply all these topics in your questions. So just put in the values. Torque dipole moment will be 2A multiplied by charge into electric field. That's it. Not even need of sine theta. So just put in the values. This is going to be 2 into 10 to the power minus 2 into 1/3 into 10 to the power minus 7 into 3 into 10 to the power plus 7. So see, 3 gets cancelled, 10 to the power minus 7, 10 to the power plus 7. Answer is 0.02 Newton meter. That's it. Quickly just copy it down. Then we'll start with force of a charge. All right. Now see, how is the motion of a charge under the influence of electric field? So torque we have calculated, formula of electric field, electric charges, all these we have seen. Generalized formula of dipole we have seen. How dipole's formula under electric field is there for axial line, for equatorial line. These also we have studied. So how is the direction of force determined? You don't have so much theory part in this. This isn't something new to you. You just have to solve the questions, but this would be related to a little bit to your kinematics equation. That's it. That's it. I'll discuss with you. For example, this is a charge. Three things you have to keep in mind: force, electric field, and electric charge. These things you have to have in your mind. Now, if the direction, if this is a positive charge, so direction of force is exactly as that of electric field for a positive charge. Now, electric field will be what? Electric field will be force divided by charge, or F is equal to QE. Now, if we are talking about a negative charge, so negative charge, same thing, it's just that you have to turn the direction exactly opposite. If electric field is situated towards the right hand side, your direction of force, which had to be towards the right side for a positive charge, now will be towards the left side for a negative. So here your force is going to be minus QE if we are taking the magnitude. For direction, obviously, you'll use your superposition principle. That is all the vector forms that you have. Now, we'll discuss a question. This at least you can do. Okay, note it down. Note down these two parts. This is the topic is, this is not torque exactly. This is how is the charge particle under electric field. Motion of a charge particle in electric field when forces are applied. Okay, quickly note these down, then we'll do in the form of questions only. See, a charged particle of +2 coulomb. So we are starting with a very basic question. This question you all will be able to solve. Slowly we'll increase the level of questions. Force is given +2 coulomb. Now see, if this is the case given to you. Electric field is given 5 Newton per coulomb. Charge is given as +2 coulomb. So force will be what? Force will simply be plus QE, right? That is 2 into 5, which is 10 Newton. But you won't write, do not just write your answer as 10 Newton and leave it. Your answer will be 10 Newton with the unit vector that will specify its direction, whether I cap, J cap, K cap, whatever is the unit vector that you have to put. But specify the unit vector at least. For example, you say, let's say in this is a positive charge. So electric field will and the force both will have the same direction for this positive charge. So if electric field is upwards, so electric force will also be upwards. So that is going to be J cap. J cap is the unit vector that is along the positive y-axis, that is upwards. So complete answer, you will write it as 10 J cap Newton. This is your complete answer that you have to put. In the second case, it's just in this second case, these are the electric lines of force. Again, electric field, this is pointing again upwards. This time this is -2 coulomb. So what will be your answer? Everything will remain the same. It's just that this is going to be 10 into minus J cap, because now the direction of force will be opposite, because this is a negative charge. So direction of force will going to be downwards. That is exactly in opposite direction. So initially it was along with electric field. Now this will be in opposite direction of electric field. So upwards was J cap. So downward is going to be minus J cap. So F into minus J cap into Newton. So that is F is minus 10 J cap Newton. This is the answer. That's it. Magnitude will remain the same. Electric field is 5. Charge is 2. So 5 into 2, that is 10. Fine. Copy this question. Some more questions we'll see that will be different from this part. Now see, this says that a proton and an electron, they are placed at rest near positive plate and negative plate. You have to find out the time period of proton and electron to reach the opposite plate. These types of questions are very common from forces under electric field. So see, this says that electron is towards the negative and proton is towards the positive. So this will move here, this will move here. What will be the direction of electric field? From the positive to the negative. We'll also study electric field lines, then this concept of the direction of electric field will become more clear. So this will be the direction of electric field from the negative to the positive charges, right? Now see, I'm just talking about first proton. All right, for proton. So force on proton, this is going to be F is equal to QE. E is the electric field. So F is equal to QE. Or I see, charge of a proton and charge of an electron both are same. What is the value of electronic charge that we studied in the first class? Anybody who remembers, what is the electronic charge? I have told you this is a very basic thing. This value of E you have to remember. What is the value of E?
1.6 into 10 to the minus 19.
Perfect, Tarif. 1.6 into 10 to the power minus 19 coulombs. This value all of you should remember. This will be used in other concepts also. Likewise, here you don't have to put in the value. So this is the electronic charge. So this is E into E. This is the force. Now see, mass of proton, let's say this is empty. Mass of proton. So F is equal to ma, Newton's equation. All of you must have studied this in laws of motion. F is equal to ma. From that, can we find out the acceleration? What will be the acceleration? Look here, class. Acceleration of the proton will be force divided by mass. What is force? Force is EE. What is mass? Mass is m. Now, let's say they are separated by this d. This is the d distance. The distance between the plates is d. So initially the velocity is 0. And what is the displacement that each has to cover? Electron from negative to positive, proton from positive to negative, they have to cover the distance d. So distance is d. Can I use this kinematics equation? S is equal to ut plus half at square. What do I have to find out? I have to find out time. I know acceleration. I know initial velocity. I know the displacement. I just want to find out this time period. So I can use the kinematics equation. Right now, I'm just referring to this proton. All right, class. Now look. This will be 0. Initial velocity is 0. This is going to be 0. Put in the value of acceleration and everything. S is d. All right. This term is 0 itself in any ways. Half acceleration is EE by MP into T square. So from here, this is time period of proton. So can't we conclude the time period is going to be under root 2 MPD divided by E into E from here. Because this was root. This is the time period of proton that we have to find it out. All right. Now for electron, what will be the difference in this? Can anyone tell me without even calculation? What all quantities will remain same? What will be the just a slight difference in the answer of time period of electron? Anyone from the class? See, you have got the formula for time period of proton. If we have to find out time period for electron, what it is going to be? No difference. This is exactly going to be the answer for electron. Some difference must be there, no, for electron. Yes, Austin, give it a try at least. Negative sign. See, negative sign we'll eliminate. That is right. You're right. Negative sign will be force. So we are just taking the magnitude right now. So that is not needed. Yes, Chavez. Would you like to try Chavez?
Mass of electron is
Perfect. Exactly. See, we are referring to mass of proton. Okay, class. So everything will remain same. See, under root, 2 is a constant, 2 will also be same. Mass of proton, so here we'll have the mass of electron now. D distance, right? So see, D separation is same for, it was for proton, so D separation is for electron also. Small e, electronic charge is same for electron, it is same for proton. Electric field, both are under the influence of same electric field, so electric field will also be same. So if you perform the entire calculation, everything, it's just that in the calculation of acceleration, it is going to be E by ME, that is mass of electron. So time period will be 2ME D by EE under root. That's it. One more thing, class. Some questions are there in your textbook which compare it. Compare the motion of, compare the time period of electron and proton. So in that case, what you're going to do? Just look, if you have to compare the time periods are directly proportional on masses. And we know mass of proton is greater than mass of electron. So time period of proton is also be greater than time period of electron in such cases. All right, if something is variable, then that's a different question. If something is variable, no, in this question, so you have to follow exact steps, whatever is the modification performed. Otherwise, in this question, everything remains same. Is this question clear to you or not? This is a very basic but a very important question from this section. Clear to all of you? At least say yes or no.
Ye- Yes.
Yes, ma'am.
Yes.
Tarif, Rabia, clear to you? Madiha?
Yes, ma'am. Yeah.
All right. Any part you're not able to understand, note it down. While writing, if you are getting stuck in any portion that you're not able to understand why we have used this step or this formula, just ask in the chat box also if you're uncomfortable to unmute yourself. Or you can directly unmute and ask. All right, note it down. So this is the way you have to just go step by step. Force, acceleration, kinematics equation. These types of questions are solved in this order. Completed class, or are you people still writing? Done?
Yes. Done.
Yes, ma'am.
Just have a look at this question. It says that a particle Q enters a region of electric field E with velocity V. Length of the plate is L. Length is given this time L. This is not the separation between the plates. You have to find out time taken by the particle to cross the plate and y deflection of the particle. See, so in this case, as I've told you, this is not a particular formula based question, right? These questions that we have been discussing, these are just based upon your logics which you have been studying, like force, distance, acceleration. You just have to relate whatever condition is given. Accordingly, questions will be modified. So two good questions which were there. One I have discussed, this I'll discuss with you. So same thing. See, in this case, now what happens when the charge is moving? That was a little different. In this case, when charge is moving, it gets deflected because of attraction towards the other plate. Because here it is not mentioned negative charge. That's why otherwise, had it been a negative charge, it would have got deflected on the other end because of repulsion. Since this is a positive charge, it will get slightly deflected towards the negative because of attraction. Now, for the first part, you have to find out time period by the plate, by the particle to cross the plate. So firstly, write down every detail that you have. Across x-axis separately, across y-axis separately. Like, we'll write about the motion along x-axis. So see, if we write about the motion along x-axis, just focus on x-axis. See here, class. Look at this figure and what I've written. What will be the separation cover along the x-axis? L, the distance of the plate or the length of the plate, that is L. Force across it, no force because electric field is along y-axis. The figure is given to us. That's why we are able to conclude these things. And figure will be given to you in the question in such cases. If not, you can derive and make your figure by yourself. So electric field is along y-axis. So no electric field along x-axis. So no force along x-axis. No force along x-axis. So no acceleration along x-axis. So all these things are zero currently. Then initial velocity is given to you in the question, that is v. This is provided by the question. That's why we are writing it as 0, ux as v. Otherwise, it would have been at rest and we would have used 0. And we have to find out time period. So once you have written all these things, once you have all the data written with you, then it's very easy to solve the question. Now see, I just have to use the kinematics equation. Ut plus half at square. Everything is just in terms of x-axis. Is it or not? Exactly. Is it this way only? So see, distance is L, ut, it's v into t, plus half at 0. See, acceleration is 0, so this entire term will be 0. So what is the time period? Time period is L divided by v. This is what you had to find. Why didn't we write the motion along y-axis? Because time taken by the particle to cross the plate will be across this only, x-axis. In the second part, it is saying deflection. Means if this was moving, this must have deflected. So this perpendicular separation, it is specially asking us. Now what we have to do? Write all the details regarding y-axis. See, we have to write all the details regarding y-axis. So now force will be there because charge into electric field is existed. Acceleration along y-axis will be there. That is force along y-axis by mass. This will be QE by M. Time period we have already calculated from the first part, that was L by V. So we again have the information regarding initial velocity across y-axis. There isn't any initial velocity across y-axis. Initial velocity was across x-axis, which we had written as x. There isn't any initial velocity across y-axis. So uy, this is 0. So now just apply your kinematics equation. Y is equal to ut plus half at squared. That will be sufficient. You'll get your answer in one line only. These help in easing the question. So y is equal to, because distance, s is equal to ut plus half at square. S is distance, ut, that is along y-axis, plus half a t square along y-axis. So initial velocity is 0. This part is going to be 0. Y is equal to half because this is 0. Acceleration. What was acceleration? QE by M. QE by M. And time period is L by V, so whole square of it. So what is the final answer that we are getting? Final answer is QE L square by 2M V square. That is the deflection, which is your second part's answer. Simply, you just have to write all the details given to you. In the first part, it was given, find out the time taken by the particle to cross the plate. So obviously the plate will cross in x-axis. That's why we wrote everything regarding x-axis, used our kinematic equation and obtained the equation, whatever it was asked, time period was asked. Similarly, we'll apply equation for y-axis also because deflection is asked and this will get deflected along y-axis only. So and whenever deflection is asked, try to make such diagrams by yourself. Yes, class, tell me, is this question clear to all of you or not?
Ma'am, this diagram will be given in exam if it is coming. So
See, if there is any change in the diagram, that will be given you that the following charge has covered so and so distance. But see, if it is just saying, like in this question, this wasn't as in mentioned in, this was a part of diagram. If the diagram is not mentioned to you, no, basic diagram is going to be this, what I have drawn. This is the prototypic question. That's why I took this question. If there is some modification. Yes, Chavez?
plate will be like this plate.
Yes, both the plates will be there. If some modification is there, no, it will mention you in the question that both the plates are positively charged like this. So you will draw exactly in same in your rough diagram or in your answer sheet, and you'll make both of these positive. Whatever is the modification given, or it will say the charge is starting from negative x-axis. Something like this. If there is anything, no, that will be mentioned in the question. Otherwise, diagram will be given by itself. Anything that is it is asked. All right. Otherwise, basic diagram is this. So practice this question. That's why I was saying this question is important. Clear?
Yes, sir.
And what about others? Austin, Faiza, Humam, Madiha, Tarif, Rabia.
Yes, ma'am. Clear.
All right. So note it down. Wherever you people are not able to understand, you can stop and ask. All right.
Can you just scroll yes.
Ma'am, can you scroll up a little? Okay, ma'am, you can scroll down.
Just text me done once you have written till here. Y is equal to QE L square by 2MB square. In the chat column, once after it writing, just text me done. And Tarif, please try not to leave the meeting. All right, try to at least give the class assessments. That will just help you only. Whichever question you are not able to understand, you can discuss it. I think like Rabia mentioned one question also in one of the classes, one question to be discussed.
Yes, ma'am.
Ma'am, in this
Can I join later? Like after it starts.
Yes, Shavir.
in this question, why deflection of particles second part? So this is displacement also
This is just displacement only.
along y-axis.
Yes, along y-axis. Displacement along y-axis. Yes. So all of you have completed? Faiza, Rabia. I think all of you are done mostly. What about Madiha? Madiha written?
Yes, ma'am.
And Chavez, you've also written?
Yes.
All right, class. So in the next class, we'll start with electric field lines. A very small topic it is. So on Wednesday, we'll complete electric field lines, Chavez and Madiha, as well as Austin. Whatever lectures have been missed by you, I'll suggest you at least try to